So in this video, we're going to go ahead and talk about raycasting. Now, picture your favorite shooter type game, whether it's Halo, Call of Duty, Gears of War, whatever you grew up playing. How do you know what you're firing at? Or better yet, when you shoot something and you see those ricochets, or when you get a headshot in a video game, how does that work? That works through raycasting. Your weapon and all the visual effects that fire out of that weapon are just that. They're visual effects. They're actually not determining what you've actually hit in your game. What is determining what you've hit is a line in 3D space that you can't see that checks for collisions in your environment. And that line is a raycast. All right, so what we do is we fire out a raycast. It's just a line that says from my weapon or my crosshair to the target that I'm aiming at. And what we're doing is we're checking for any intersections between where I shot from and where I'm pointing at. And if there isn't a line, and if there is an intersecting point, then that is what we hit, and we can go ahead and we can change the color of that object. We can check if it was a headshot. We can go ahead and add force, make something explode, based off of whatever information is returned to us from that ray. Now, raycasting in Unity can be seen as an intermediate topic as well as can be quite complicated, but it really doesn't have to be, and I'm going to try and make it as simple as possible for us. So what we're going to do in our game is if I enable my weapon here, let's click on our weapon and go ahead and turn that game object back on. You might think, where do we want to cast this raycast? We're not actually going to be casting it through the weapon itself because the weapon itself is tilted and pointed at a very odd angle. Instead, we have the illusion that we're aiming down the center of the screen. So we're going to cast our ray from the center of the screen using our main camera. And that's going to basically cast forward into the game world. And whatever we hit, we can go ahead and get the name of the object, we can go ahead and add force to those objects, and eventually throughout this demo, we're going to be able to destroy crates and bottles. So let's go ahead and look at how to set up raycasting. The first thing we want to do is head over to the scripting reference and look at what raycasting is and how it's used. So let's go ahead and open up your Google, go to the scripting reference. You can hit the blue icon little book in Unity. And let's go ahead and go to Scripting API, and let's type in raycast. You're going to find something called physics.raycasts. And what this does is it will cast a ray from an origin point in a given direction with a length, which has a max distance, against all your colliders in the scene. Okay, so with raycasting, here's how it works. We have a physics.raycast. This is how we actually cast the ray. And the reason why it's in an if statement here is because it returns true if you hit anything. So if you hit anything in your scene that has a collider, then it's a true statement, and we can go ahead and print out there is something in front of the object. So for this example, they are saying, I'm going to cast a ray from the player's position, which is transform.position, a forward direction, which they have declared up here, and then they're going to say that the distance of this ray is 10 meters. So for instance, say you had different weapons. You could declare a distance for how far these weapons can shoot. So if you had a shotgun, the distance might be 5. If you had a rifle, it might be 30. So for us, the distance isn't really super important for this example, but it's just to get you familiar with raycasting. So with raycasting, it can be seen as quite intimidating because there's two parts to raycasting. There's casting the ray, and you have to declare an origin position for that ray, and then there's getting information about that ray. So I'm going to go ahead and split this up into two parts. The first thing I want to do is I want to cast the ray from my main camera, and that's all I want to do. I just want to know if I hit anything that has a collider. So how can I cast my ray from a main camera? If I do if physics.raycast, I can cast from my player's position, but we don't want to do that. I want to cast specifically from the main camera. Now, looking at some of these other examples, I believe they actually have an example of just that. Same as above, using ray.origin and ray.direction. Instead of origin and direction, let's see here. Not extremely helpful. However, this is what we want to use. This right here, instead of using your transform.position, we can specify a ray. And what this is, and it's a little confusing when you look at it as ray, you could think of this as the ray origin. So where's the ray origin for us? It's the main camera. And you can see here what they're doing is they're saying ray, or ray origin, equals the main camera, and then screen point to ray. And what they're doing here is they're casting a raycast from your mouse position. For us though, we're going to actually cast it from the center of the screen. And I'll go ahead and show you how we can do that, because at the end of the day, input.mouse position is just a vector 3 position. Well, using a vector 3, I can also get the center of our screen. And looking through this, just to make sure, we also have, yeah, I think that's it. I think we're good with this. Okay, cool. So let's go ahead and head back into Unity and let's set up our ray. So the first thing we're going to do is we're going to go into our player here. And what we're going to be doing is, the objective here is we're going to cast a ray from the main camera using the screen point to ray. So let's go ahead inside of update here, and let's go ahead and actually create the logic for actually firing our weapon. So for us, we're going to be firing our weapon when we left mouse click. Every time we left mouse click, I want to go ahead and cast a ray. So how can we do this? Well, easy. If left click, cast ray from from center point of main camera. And we know that we're going to be using the screen point to ray. So here, if we left click, let's just start filling this in, right? So here we have our if statement. We have our left click, so if input dot get mouse button down, and 0 is for left click. So if we left click, then what do we want to do is we want to cast a ray from the center point of the main camera. So what is the center point of the main camera, and how do we actually cast the ray? Well, when raycasting, everything starts with a ray origin. Where is this raycast starting? So we declare a ray, and then give it a variable name. This can be named anything, but I'm going to call it ray origin so that it makes the most sense. And the ray origin is from the camera.main. This is a quick tag provided by Unity to grab the main camera, and then we're going to say dot screen point to ray. And you'll see here returns a ray going from camera through a screen point. And you'll also see that we have viewport to screen point, world to screen point, and we have a few other options. We will be looking at another one of these, more specifically viewport point to ray, and I'll explain the difference in a moment. So here we have our ray origin, and we say camera.main.screen point to ray. And now this takes in a vector 3 position. So the position is basically the center point of my screen. Now in order to get this position, we have to do a little bit of math here. So screen point to ray basically is going to take in a vector that is the length of our screen. Now we know whatever computer you're playing this on, we can get information about the screen that the user is using. And the way we can do that is I can actually say here, for instance, I could say screen.width, and that gets me the width of your screen. So what I need to do to get it in the center on the X is I need to say screen.width and divide it by 2. That will go ahead and get me the center point. The next thing I want to do is I want to say here screen.width divided by 2, and then for the Y, I need to do the exact same thing. So we're going to say screen.height divided by 2. And then for the Z, it doesn't really matter. We can go ahead and keep it at 0. So we go ahead and save this. And we may want to just make that a float, just in case. And now what we can do, we'll go ahead and close this off. So here we have our ray origin, camera.main, screen point to ray, and it needs to be in a new vector 3 format. It's giving me an error here because what you can see here, it's asking us to put in a vector 3 position. Anytime you see a vector 3 like that in the tooltip, it requires a new vector 3. So screen.width and screen.height, and we're good. Okay, so this is the ray origin. This is going to cast a ray from the center of the screen. Now, in order to check if we hit something, I need to actually do the casting of the ray, which is this. If physics.raycast. This is what's actually calling on the physics system to cast that 3D line in 3D space so that we can check for collisions. And as you can see here, we have about a dozen options to choose from, more than a dozen. And what I want to use is the ray distance. Let's go ahead and say, yeah, let's go ahead and use the first one. So here we have a ray, which is our ray origin. We can specify a distance for this ray, and then we can specify a layer mask. A layer mask is basically a visibility mask. So for instance, to avoid friendly fire, you can make this ignore a certain layer or look for a certain layer. a little bit out of the scope of what we're doing, but layer masks can be heavily useful. So here we go. So if physics.raycast, what we're going to go ahead and do here, and let's see if there's actually one where it's just the direction and so forth. Looking at this, we have ray out. Oh, here we go. Yeah, this is just a ray. Here we go. Ray and distance. That's all I care about. Let's go ahead and do that. So if physics.raycast, we're going to say ray origin. And then how far can we fire this? Let's go ahead and say infinity. So we'll say mathf, which is the math library of Unity, followed by .infinity. Now, if we hit anything with a collider, we'll go ahead and print out debug.log raycast hit something. Let's go ahead and save this and return back to Unity. Go ahead and run your game. And now we're casting directly through this. And if we hit a collider, you'll start to see that things in our environment will start printing out. I need to find a collider. There you go. So if you aim at the floor, it says Raycast hit something. Now looking at our shark guy, we have no colliders here. So let's go ahead and add a collider to the shark himself, just so we can know that we're actually pointing at him. So if you click on the shark here, you'll see the shark man. Go ahead and add component, box collider, and then let's go ahead and edit the collider so that it takes up majority of his body here. Okay, let's go ahead and save our scene, rerun this, and now when you're pointing at the shark, it should say hit something. And you'll see here, if I point at him, it's not, oh, there you go. Oh, sorry guys, it's when you left click. Remember, we have logic that says if you left click, cast a ray. So there you go. I'm hitting the shark, and I'm hitting the floor, and anything that has a collider will pronounce to me that we're hitting it. So now it comes down to, how do I know what I hit? Because in our game, you know, I might want to determine I can only shoot certain things. So what am I hitting? How can I get information about what I hit? That leads us to hit information returned to us from our array, which we'll get into in the next video.